Good morning, everyone. It's great to be here online with you. I just wanted to see how everyone's doing, so please send me an email. Let me know how the virtual classroom experience is going for you so far, and I would also like to hear your feedback on this video as well after you watch it today. So to start out with, let's take a look at right triangles. Right triangles, we know, have three sides and one angle that equals 90 degrees. We know that one side is longer than two of the other sides. This diagram you see here will be very helpful in today's activity and assignment that I have listed for you in Google Classroom. So as you see, there is an opposite, an adjacent, and a hypotenuse side, so just keep that in mind for today. Also, if we take a look at two-step equations that you learned previously in your algebra classes, we have an equation here. In this two-step equation here, you have a fraction x over 5 plus 7 equals negative 3. And they first subtract 7 from both sides, and then after they subtract 7, the positive and negative 7s cancel out, and the negative 3 and the negative 7 are combined together to create negative 10. Now there is a new equation, x over 5 equals negative 10, and we will multiply by the reciprocal, which x over 5 represents 1/5 that fraction. So we will multiply by 5, or also known as 5 over 1. There's just not the 1 written, it's understood. So then we cancel out the two 5s, and the other 5 multiplied by negative 10 will become 50. Well, actually, this is a little bit of a typo. I took this image offline, and that actually should be negative 50, because we know that if we multiply a positive number times a negative number equals a negative number. And we also know that whatever we do to one side of the equation, we must do to the other side of the equation. Now that we have reviewed those concepts, let's take a look at today's activity. If you look in Google Classroom, I have uploaded a document of notes with the Pythagorean theorem. This is one of my favorite math theorems. It is fun and easy to use once you learn how to do it. So if you will notice, the document comes in English and there is a version in Spanish. You may use both of them, or if you just choose one, you can use whichever document works well for you. There's also a key that I will upload after this video is recorded, and I just ask that you will please look through that key once you have worked through the original notes and problems individually. So let's discuss here. A let's look at our triangle image. We have, in the case of a missing hypotenuse, the hypotenuse is the longest side. The longest side here is 5, and the other two sides are 4 and 3. So just take a moment and look at that equation for a moment. Now that you have paused this video and started to play it again, and you've taken a moment to look at this equation, let's discuss this set of guided notes here. So what you will want to write, where you see these first two blanks, you will write the words proven relation, so that it will say a proven relation that and in this next blank, you will write the sum of these squares on the legs of a right triangle is equal to the square of the hypotenuse. So again, in those blanks, you should write in the first two, proven relation. In the third one, you should write sum. In the fourth blank, you should write legs. And in the fifth blank or final blank, you should write hypotenuse. If you notice in this first equation, the variables a and b are known as your legs. That's why it is plural. And your hypotenuse is the longest or the third side, which is the hypotenuse. If you look in this equation, we have already previously learned how to add and subtract different variables and multiply and divide them. In this case, we also have variables that are squared. Now, you did learn how to square a number in algebra. So if you had 4 times 4, 4 times 4 would be 16. You would also know that the square root of 16 is 4 because 16 is made up of a number that multiplies by itself. It is a perfect square. And we have also talked about how to solve square roots that are not perfect squares, where you may have a number on the outside of the radical and a number remaining inside of the radical. So with this missing hypotenuse, you would have the legs A and B, which would be 3 and 4. You would have 3 squared plus 4 squared. And as you know, 3 squared equals 9. 4 squared equals 16. And you would have equals c squared because we know that we do not know that variable. And you would add the two numbers. You would add 9 and 16. You would get 25. You would take the square root of 25, which would give you 5. And 5 would equal c. C squared would be 25, of course. And for the missing leg, you can rearrange the equation if you'd like with c squared minus a squared equals b squared. As you also see with this equation with c squared minus a squared equals b squared, they rearranged and put c squared in the front, subtracted a squared, and made it equal b squared. So 5 squared again would be 25, and minus 3 squared, which is 9, which would give you what? It would give you 16. 25 minus 9 is 16. Then you would take the square root of both sides. So you would have 25, you would have 16 equals b squared. You take the square root of both sides, so you'd have 4 equals b. Let's take a look at some practice problems. So I would like for you to pause this video and go ahead and practice the first two problems on the left-hand side where it says use the formula to find the missing hypotenuse. Using the method we discussed, you should have gotten 25 as your hypotenuse for the first question and 24 and 2/10 for the hypotenuse on the second question. Now please pause this video and try the second two problems on the right-hand side, where you will be finding the missing leg. So if you take a look at after answering those two problems, you should have gotten, your answer should be 15 for the side B, and 23 and 8/10 for side A. So once you have gone through some of this any extra practice on here, or if you want to see the Spanish version, I will provide a document with that key. Once you have completed this and you look over all these questions, I need you to go to the GimKit link in Google Classroom. Now, once you click on this, it will say the Pythagorean theorem as the title. And you will choose a game of your choice, any game that you would like to go with this assessment. And once you hit continue, well, this is for my thing, I put a game duration. For y'all, it will be unlimited time though, just like in this case, it says 10 minutes. For y'all, it will be unlimited time. Once you get loaded in, you will have a character and you may begin your game. We will have a Zoom Live that we can use for this. And once you have watched this video, we will all join in this GimKit link together. Your code will look something like this. It will be a different 6-digit code. I need everyone to email me when they are ready to begin the game, and I will set that up for y'all. So thank you so much for watching. I hope you all have enjoyed listening and learning about the Pythagorean theorem. So as you know with your algebraic equations, always to do what you do to one side of the equation, you must do to the other. And when you take the square root of a number, you must look at what may be multiplied together to be taken out of it. And if there's a perfect square, that is the number multiplied by itself, which gives you the larger number inside. Thank you so much for watching, and I hope you all have a great rest of your day. And please let me know if you have any questions. Bye-bye.